Hey guys, so this one says the following diagram shows triangle ABC. The point D lies on BC so that AD bisects BAC. AB is equal to 2 rad 5, AC is equal to x, DAC is equal to theta, where sine of theta is equal to 2/3. The area of triangle ABC is 5 centimeters. I feel like this is my only really useful clue, and possibly this. So find the value of x. Okay. So they gave me the sine of theta is equal to 2/3. So I feel like the sine of theta equals 2/3 is a great place to start. So I am going to first take the sine of theta equals 2/3. And I see that that is isolated in this tinier triangle down here. Okay, so it's like A is here, theta is here, x is here, D is here, and C is here. Okay, so the sine of theta would be 2/3. I've got, in order to do the area of a triangle, I am going to need the cosine of theta, because if I'm trying to find the area of this big triangle here, right, I'm going to need the sine of 2 theta to be my included angle, right? So in the sine of 2 theta, I'm going to need the sine of 2 theta is equal to 2 sine theta cosine theta. So I have sine of theta, I need to find cosine of theta, and I'm going to do that using my Pythagorean identity. Okay, I've got a good plan here now. Let's take care of biz. So I have sine squared theta plus cosine squared theta equals 1. And I'm going to do 2/3. I'm going to square it. And then I'm going to add the cosine squared theta is equal to 1. And then I've got 4/9 plus cosine squared theta is equal to 1. I'm going to subtract 4/9 from both sides. I'm going to turn this 1 into a smart version of 1, which is going to be 9/9. So I have 9/9 minus 4/9. I now have cosine squared theta equals 5/9. I'm going to square root both sides. I have the cosine of theta is equal to rad 5/3 plus or minus. Okay. So I am talking about measurements in real life, not superimposed on the coordinate plane. So I would not be dealing with a negative cosine in this case. So I'm just going to take the positive version. And I now have my cosine. So I can use my area clue to try to solve for x. So the area of the big triangle here, right, is equal to 5. So in order to use my area formula, I need this side for A, this side for B, and this included angle here for the sine of C. However, there are 2 thetas, so he's going to look like the sine of 2 theta. So that's how I kind of figured out that I needed to get a cosine, because I needed to figure out what the sine of 2 theta would look like in this case. So now I have area equals 1/2 AB sine of C. The area is given as 5. I have 1/2. The side that's next to me is 2 rad 5. B is x, and then the sine of C is going to be the sine of 2 theta. So let's rewrite that with our double angle formula, which is going to be 2 sine theta cosine theta. So now I have 5 is equal to 1/2 times 2 rad 5/1. I'm kind of splitting everything up because I'm like, I'm going to end up having to multiply all these fractions by hand. So, all right, we got x/1 times 2/1 times the sine of theta was given as 2/3, and the cosine of theta is rad 5/3. So let's kind of see what we can cancel and whatnot here. All right, so I got 2/2. Those are going to cancel. Is that it? Yikes. Okay, so I've got rad 5 times rad 5. He becomes a 5. And then I have 2 times 2 is 4 times x. Okay, and that is all going to be over 9. So now I have 5/1 is equal to 20x/9. I'm going to cross multiply. I have 45 is equal to 20x, divide by 20, divide by 20. And I have x is equal to 45/20, which reduces to 9/4 if you also got that and want to see if you're right.